Hi, I'm going to present a research entitled Method Validation of Arsenic, Cadmium, Chromium, Cuprum, Mangan, Nickel, Selenium, and Zinc metals in Citarum River sediment using inductively coupled plasma optical emission spectroscopy. The agenda of my presentation are introduction, methodology, objective, result and discussion, and the conclusion. Most media said the Citarum River is the world's most polluted river, where over 35 million people rely on it. The Citarum is the source of water for the Jatiluhur Reservoir, which is Indonesian Raja Reservoir for 3 billion cubic meters of storage capacity. The reservoir not only supplies clean water for Bandung, but also provides 80% of water supply for the capital. It also irrigates 400,000 hectares of rice fields and is a source of energy for 3 hydroelectric power stations serving 3 cities. Clean water is improve the quality of drinking water, improve crop yield, and the long-term revitalize the ecosystem and the volume of fish in the river. And when downstream canals are not clogged with garbage, artistically placing crystal clean river water will make riverside property more attractive and result and water tourism can grow prosper. How high the Citarum River sediment heavy metal content now? The heavy metal go along into the river with transport to the sediment. The amount of heavy metal in sediment will increase when the industrial and human activities are also increasing. Sediment, quantitatively, is known to be major compartment for metal storage in aquatic environment. Concentration of metal in sediment is the first step to indicate the condition of the environment and provide a baseline information on the possibility of metal contaminants bioavailability to the biota. If they are accumulated with some enviroorganism, they can easily incorporate it into the food chain and cause serious disorder or diseases. There are two major instruments usually used in the laboratory for measuring the metals, like flame atomic absorption spectrophotometer and inductively coupled plasma optical emission spectroscopy. The advantages of the using ICP are firstly the sample volume for the ICP-OIS only need 5 mL for the multi-elements, while the AA need 10 to 15 mL for the single element. The interferences, the ICP-OIS for very few, but in AA quite many. The limit detection can go to 10 ppb for ICP-OIS and 100 for the AA. The precision for ICP-OIS can go to below 5%, while the AA only between 10%. The dynamic range is quite high, quite wide for the ICP. It goes to 1 million, and for AA is 1,000. The sample preparation for the ICP-OIS is easier than the AA, while the measurement cost for the ICP-OIS is low-medium compared to AA is the medium. To get an accurate and precision of the measurement, the method should be validated. The parameter of validation was measured such as linearity, precision, accuracy, limit of detection, and limits of quantification. Precision, we calculate the RSD, the relative standard deviation, when we compare the value to the CV Horwitz. While the linearity, we calculate the coefficient of correlation. The accuracy, we compare our research result with the PAC3 CRM. Limit of detection was calculated by the blank plus 3 standard deviation, and limit of quantification we calculated by blank plus 10 standard deviation. The objective of this study is to validate highly specific, reliable, cost-effective ACVOS method to determination of sediment by measuring above parameter. Method validation is basically the process of defining an analytical requirement and confirming that the method under consideration has capabilities consistent with what the application requires. There are 4 steps of the study design. Firstly, sample preparation. Follow the APA method number 3050B. Secondly, method validation based on Eurochem 2014. And thirdly, sample measurement, which include and validate using PAC3 CRM. And lastly, the research result compared to the Australian and New Zealand guideline for the fresh and marine water quality interim sediment quality guide. The method validation results are as follows. The strength of the linear association between two variables of quantified by the correlation coefficient. The correlation coefficient always take a value between -1 and 1, with 1 or -1 indicating perfect correlation. That means that all points would be a long line, a straight line in this case. Relative standard deviation, which also may be referred to as RSD or the coefficient of variation, is used to determine if the standard deviation of a set of data is small or large when compared to the mean. In other words, the relative standard deviation can tell you how precise the average of your result is. A low standard deviation indicates that the value tends to be close to the mean, also called the expected value of the set, while the high standard deviation indicates that the values are spread over the wider range. The recovery value of each metal was found acceptable for the concentration between 1 to 10 ppm was 80 to 110%, and 10 to 100 ppm was about 90 to 107%. However, the recovery of cadmium was found lower, as the cadmium metal might be evaporated during the digestion process. There is no information on selenium metal value on the PAC3 CRM. The limit of detection for arsenic, cadmium, chromium, nickel, and selenium metal was found below 10 ppb, except for zinc, mangan, and copper. The qualitative result of the sediment as follows. Cadmium and selenium metal in situ river sediment sample were found below the LOD value. It means those metals are not detected. The concentration of metal in sediment occur in station 1 give higher value compared to station 2 and 3, as we can see in this figure. The metal measurement result was compared to Australian, New Zealand Environment and Conservation Council Interim Sediment Quality Guideline Standard. The nickel metal concentration was found 27.7 ppm, higher the ANZ-ECC low standard of 21 ppm. Zinc metal concentration was found 389.4 ppm compared to ANZ-ECC-IS-QG low standard of 200 ppm. Mn metals value in sediment sample was 795 ppm and no information for the standard. Zinc and mangan metal are major metal in the sediment samples, while others metal are heavy metals. Chromium is used as a pigment in paint and in process such as manufacturing stainless steel, treating timber, tanning leather, and electroplating. In this study, the highest concentration of chromium was 61.5 ppm, occurred in the station 1 and the lowest was 39.8 ppm occurred in the station 3. To conclude of this research are the method validation of ICPOA is found satisfactory for determination of sediment. Recorded metal concentration from all stations in May 2018 was below the relevant of ANZ ECCISCZ low trigger value, so they are not harmful for the environment. Concentration of heavy metal at Station 1 are potentially concerning for the industrial waste and human activities, so that the monitoring sediment concentration is needed. That's all my presentation. Thank you very much for your kind attention.